Hi, everyone. Welcome to our Ask a Greenhouse Expert webinar series hosted by Ceres Greenhouse Solutions. This is a continuation of a previous webinar from last month on strawberry growing in a controlled environment. We had so many good questions, we decided to spend a little extra time just answering those. So for the next hour or so, we will dig a little deeper on the topic. My name is Miriam, and I will be the host for Strawberries Part 2. Just a super quick intro this time around. Once again, we bring you our two special guests, Claas Ahrens. Claas Ahrens is the founder of vGreens. For more information on Claas, we will link to his website in our previous webinar. Sebastian.pook. Sebastian is a plant production systems designer at Koerber Technologies, and to learn more about Sebastian, we will also link his contact. And representing Ceres, we have our hosts, Josh and Mark, and also helping us, Haley. Before we get into it, we have a quick disclaimer. The information provided during this webinar is for general informational purposes only and is based on the expertise and knowledge of our greenhouse specialists. The advice and recommendations provided are intended to assist attendees in understanding various greenhouse systems. Participants are encouraged to consult with a qualified professional or conduct further research to address any specific concerns or requirements they may have. The hosts and organizers of this webinar are not responsible for any actions taken based on the information presented. All right, so let's just jump right in with our questions. And we're going to start with just a little bit of a broader, all-encompassing question about strawberry growing. What has changed in the industry to make strawberry growing such a popular and economically viable crop? Sebastian?
Yeah, so from the view for indoor farming, in the last years, you had, or generally over the last decades, you had a very big improvement in lighting technology, so that producing completely indoors is much more viable there, and also many of the reasons I think is that when producing indoors, you need to target higher value crops. So as many companies in this space failed in the last years, and there was and which mainly focused on leafy greens, there was a big focus shift on for many of the players in the market, trying out products that have a higher margin. And of course, there's also a shift in the demand, because also just recently in the news again that, for example, in Germany now, strawberry prices are probably going to be rising again, because just also with climate change, many of the traditional growing areas don't produce that well anymore. So everybody's looking for alternatives now.
Yeah, I think that's super interesting. I think that what we see is maybe there's the consumer base is becoming more educated about what a strawberry could taste like, which increases the value of a strawberry once people realize how delicious they should be. And I think on our end, what we see, because we saw this in cannabis, which is they're quite similar in how this goes, is that LED technology allows indoor growing to happen. There's a big financial investment into doing it. Some people fall off, and then it starts to get focused on what can really produce income for a farmer. And I think strawberries are a cool place there, where producing them more local to urban centers is potentially quite a viable solution, which is why I think we're seeing what we're seeing.
Maybe to add, from the CEA perspective, there's so much potential in the strawberry crop itself, which can be discovered throughout a manageable farm system, so that a common yields per square meter can be boosted to a certain extent, in which the viability comes into place, not only with LEDs, but also in hybrid solutions.
I had a question for Claas on this same topic, which is really from my understanding, most of the crops, the strawberry crops so far, were really meant to be outdoor crops, right? They have certain peak production times, and then they drop off. And the industry, as far as I have learned, is pushing more towards hybrid crops, or crops that are really designed to be grown in greenhouses. Can you tell us a little bit about that? Well, whether or not greenhouses or indoors is, for me, at this point, it's the same. But the requirements are different. So maybe you want to talk about that, because that will affect the profitability once you get strawberries that are optimized to grow indoors.
Yeah, two things to say to that. So first, maybe starting with the benchmark where all those common supply chains come from, is that we are obviously dependent on seasons, which makes it quite a benchmark behavior in terms of delivery times. For example, let's take the German example, and you can apply that to almost every part in the world, maybe not the actual month, but normally we start growing strawberries from Jan, Feb on, and get the first strawberries delivered in calendar week 14, 15-ish. And then we have those regional strawberries in our supermarkets. So all the other times it's common to import. And this kind of phenomena we find everywhere, especially in the Middle East, very hard, because they almost import 90%. So that means that you have a certain culture which is trimmed to exactly hit those time spots from let's say a propagation phase, and then a production phase, and then what you said, it's dropping. And through CEA, we now have the possibility to impact on the input we put on resources onto a plant. And now it's really important to understand that there are so many different strawberry variety types, from June bearer to everbearer, neutral day, long day, and so on and so forth. So there are so many different application towards a strawberry variety itself, that you need to find the right combination on the timing and the certain quality, shelf life, and all those aspects you want to see in a strawberry, and then you have a mixture of all those demands for your production. So it's not easy to say there's this certain thing, but it is definitely worth saying that CEA enables an impact on the actual production cycles, which can enlarge the time of production, but also takes care of the plant health. Because normally, let's take a June bearer, you take 4 months and you have your first flush in after, like, let's say 2 months-ish. And the second flush, where you maybe also get a certain portion of production, it's always lower than the first one. But the energy household within those plants can be controlled through CEA. And that's where the magic happens, that you maintain a crop for longer, so your overall yield per plant can be managed in a better way than we see that at the benchmark right now, especially in conventional growing.
Wow.
That was a mouthful.
Yeah. Let's move on to, we have some very specific growing questions. First one is, how do you pollinate strawberries in a sealed environment?
Well, I'd say I'd go ahead. We know the benchmark, I think invented by the Dutch as well, is put a bumblebee hive in your greenhouse. Same thing with CEA, put a bumblebee hive first in your system, and make sure that the bumblebees are, let's say, steered by UV light, because they are basically blind if you just use the normal spectrum. So you need certain UV traces that the bumblebees find their way back home. in those hives. But that's something you need to consider in your design. So you cannot just build as high and wide and everything as you like if you would like to have a pollination through bumblebees. So this is always to be taken into account, that you basically take care of the trace bumblebees have to take.
Claas, I just visited a greenhouse a few weeks ago in Washington State in the US. And through regulations, they're using bumblebees, but they can't have a queen, because if they leave the greenhouse or something, they need the bees to not reproduce and to stay in the greenhouse. And so they're constantly reordering bumblebees because eventually they're dying. Is that normal, or where you
That's
are?
a normal procedure, 6 to 8 weeks per hive, depending on the amount of flowers you will find, because that's the ratio you want to look at, is how many flowers per bumblebee, basically. You normally calculate the hives per plants, and that calculates in the certain production phase, because if you have too less flowers, bumblebees like to eat more than just their food, but rather also some flowers, which leads them to damaged crops. So the balance is very crucial and shall be tracked, hopefully on data, but most of the time in the benchmark, it's the let's say subjective obligation of the farmer itself.
Cool. Are there other methods, or is bumblebee the method?
Oh, yeah, there are, but they are dependent on the region. Normally, we just try to use bumblebees, but you can use also flies, bees, and what we've seen is a startup for drone, like micro drones. I haven't tried it yet, honestly speaking, but I would love to. Although it seems to be an overkill for now, I would love to see that, because this is something which needs to be, let's say, considered with the biggest impact on rejection rates is failed pollination. So I think if you look at the rejection rates between 5 to 15%, depending on how you grow, it is a factor which needs to be considered, and basically 5%, that's a thing.
Yeah, interesting.
And can I just ask, the 5% failure rate is basically, those are 5% flowers that basically don't convert into strawberries. Is that what that is?
They will convert, but they won't be usable to a certain extent. You have class 1, class 2, and then let's say those ones you mix into like the next production of yogurt or whatever, or frozen fruits. And then there's the fourth category where you're not even able to sell them further on the supply chain. So those 5% relate to the last aspect.
Okay.
So we had a lot of questions about fertilization even after our last recording. I was just wondering if we could revisit this topic, more about substrates in particular, and blends for vegetative versus flowering, if there's any thoughts on any of these topics.
Yeah, maybe I can give my 2 cents on the substrate. Just a disclaimer: I'm not the expert of irrigation, and especially not the chemical part. But if there's certain interest, I'm happy to share afterwards. But I'm not the specialist in this one. But regarding substrate, it is always a matter to figure out the C and pH values, which is like the most mandatory values to overwatch and make sure that this is in place. Once the pH drops or it gets too high, especially too high, the crops will fail. So it is very important to understand your substrate. It can be a boost if we, for example, look for biochar, for example. So you boost it with those certain elements within the substrate. But it needs to be, as said, in balance with the actual fertigation regime. And if you try to be as basic as possible, I think cocoa coir is one of those most used substrate. There it's more easy to apply, or let's say, certain standards in the irrigation scheme. But as said, when it comes to the actual bits and pieces or the particles, I'm not the right expert, as well as the right amount. It always differs regarding the like how much do I need to irrigate and how much fertilizer do I need to use. As said, if there's certain further questions, I'm happy to answer afterwards.
Maybe adding on to that, so not in terms of chemicals, but in terms of how you do the irrigation. So there's many different ways of doing it. So in a greenhouse or generally closed space, people are not really using sprayers for strawberries. Some people like wick systems, or even aeroponic systems. But what is probably for newcomers the most interesting, also safe way is to use drip irrigation, because you can be sure that all of your pots get the right amount of water, and you always know that what they're getting is the freshly mixed nutrient solution. So you always know what the plant gets as well. And another benefit is if you screwed it up or something went wrong for another reason, you are able to flush out excessive nutrients by just adding a lot of fresh water, and therefore saving your plants and not killing them all.
Yeah, a question I had, and Mark, I mean, we are not the researchers, we're just learning from researchers. But what we've been told over the past year or two that we've been doing this is that the strawberries really don't like to pull from the bottom. They really do want to be top fed. And I think that's maybe that it just hasn't been fully investigated, but so far the best results have been top drip. And Mark, you could chime in on that. The other thing I was going to say real quick is, like, I've seen a lot of cocoa perlite blends as the media, and the one I was just in, they said that media could last for 5 to 8 years without replacing it. And I'm wondering, Claas, I mean, I don't know with the systems you've been doing, if you reuse it, or after every 9-month, 1 year cycle, you're getting rid of it and starting over.
Oh, well, partially. It always comes with contamination in such terms. So we need to make sure that we get rid of any bacteria which starts developing within the substrate over time. And therefore, we do certain tests before we reuse it, and if it's clean, we reuse it, and if it's not, we just chuck it out and get it out as fast as possible. Every kind of root disease or anything else, it's killing you, so no hesitation, try not to open up another level of risk.
Yeah, as well, also of course, substrates, especially if they have a very high organic content, they also start basically composting over time. So if you're using them for a longer time, after a year, you will have a completely different build-up than you had in the beginning. So you would need to adapt your other strategies as well. So often it might make sense to exchange it just for those reasons alone.
Yeah, these were, cocoa perlite, is really just a soilless media, and then the plants are being fed, and so there's, very little or no organic matter in the soil, and they were saying they could just continue to use it, which I understand how that's a little bit scary with pathogens.
Exactly.
But I thought it was interesting. It's because that's a cost, that's an ongoing cost, and so if you can make it work for longer, that's a kind of an interesting thing to think about. I think
as long as your process of reusing is safe and trained well.
Yeah.
So especially what we found is if you have like rotten root problems, then try not to get every cent out of the substrate.
Yeah. Mark, do you want to comment on uptake versus top drip? I mean, I know we don't know a ton about it, but
Well, I don't know that I'm the right person. I did learn a lot when I went to visit Claas's facility together with Sebastian. They were having a facility in Germany where they tried these different methods of feeding the plants and had very different results. I know what I learned from those and from others, but you guys are the experts, so why don't you want to talk about using methods that are generally used in the leafy green category, NFT systems, etc., which I have learned from you guys don't work very well. Maybe you want to say something about that?
Yeah, sure. So basically, there's a ton of possibilities to get the nutrients to the plant's roots. Which is really hard to discover is the health rate of the microbiome itself, which is basically raised by using substrate. Because too much difference within the area where the roots are in, if that changes too quickly, the microbiome gets destroyed every time. So the microbiome is also like an immune system for that area. So it's really, really tough to manage a crop over time without substrate. So that's why we see a lot of lettuce being grown in NFTs or aeroponics especially, because you need a mixture of a good microbiome, but also a good art of oxygen availability. So aeroponics therefore works so well for salads, for lettuce, but this crop only grows for like 20 to 35, 40 days, depending on where you are and what variety you're focusing on. And afterwards, you don't need to manage, you just need to chop it. So a strawberry plant is I almost say closer to human, but it is so hard to manage. When I get back to the flushes, it is so it's such a huge let's say different parameters influencing the actual health, but also the performance of the plants, leading to yield and quality, of course. And on that road of the combination of energy level and all the parameters influencing the plant, it almost gets impossible to manage the crop without substrate, because you need to erase that issue as good as you can of too much changing parameters, especially in the root section. So even if you look at the leaves, even if you change it too fast here, it's impacting the plant very bad. And if you get to the point where the nutrients are taken into the plants, it's even worse. So I can definitely say if you have a crop which only lasts for 30, 40, maximum 50 days, go ahead, do it in NFTs. But if you want to have a plant like a strawberry plant for 4, 6, or even 12 months, not without substrate.
well, so let me just go a little deeper with that, which is, can you use NFT or aeroponic, below with a substrate, and does it work, or is still top drip the best answer in a substrate?
A great question. Still gets into almost the same direction. So let's say you have a certain amount of substrate per plant. This is basically like the reference I would start with. For what you just said, I assume you meant like you have a basket, for example, let's say 200, 300, 400 milliliters per basket.
What does that mean?
Sorry?
That was a milliliter joke.
Yeah.
Okay, keep going.
Half a liter, which would be what, like a pint and a half or something?
Okay, great. Yeah, okay.
It's evening time in Germany, so I think I can definitely assume that's fine. No, anyway, so you have a certain milliliter amount of substrate, and those roots will grow out of it. So you might be able to extend those 30, 40, 50 days to 60, 70, 80. But after such, your roots start clocking after they grew out of the substrate. and then will clog together, and the mold will start growing within the centerpiece of that root system. So that means hypoxia will come around, and there's too less oxygen on the main root parts. And that basically is a huge problem for the plant health, and then you can start chucking it. So what you want is that the root system itself gets the aeration within the substrate on the one hand side, and second of all, you don't want to have this hypoxia problem due to those clogging root systems. And last but not least, we currently go between 1.5 and 2.5 liters in substrate. So we can make sure that the root system, as it is also growing next to the actual plant age, that we can maintain the plant up to 12 months.
Okay. So I'm still at the thing where it sounds like top drip.
Oh, sorry, yeah. We do top drip. You have this needle where the drips come.
But it seems like with top drip, the roots will stay within the media because the moisture is in the media. Whereas if you're feeding from below or something, the roots are going to try and push through the media to get to the water, at which point you start having those issues. Hypoxia, mold.
The roots will grow anyway. Like they try to grip somewhere, so they will always try to stay within the media. They are only happy to grow out of the media if there's no space left. And yeah, so I would definitely recommend a top drip. Yes. Yes.
Nice.
Sebastian, do you have any opinions?
Well, so my strawberry experience therefore is somewhat limited, but so it's very dependent upon the crop how they react to the different irrigation techniques, and especially sometimes when the wicking is not strong enough. Like when you have a bottom fed system and the wicking is not really strong, then of course the plant tries to push down as far as possible. But sometimes it's also something that you want because in the beginning the plant is growing slower, and then you can give it kind of a boost by irrigating it from top as well. So you can also control with the balance of that how the plant is developing. But also some plants, if there's not enough water coming up, they just might give up and just grow very slowly and not necessarily fight to get to the water.
All right. I think it's time to move on to some more equipment-related questions. There was a question, if switching from a different crop, what equipment can be reused and what is specific to strawberries? So growers may be already growing lettuce or other fruiting vegetables. Is there equipment there's no substitute you need for strawberry growing?
Can I ask you, Miriam, just to make sure I understand the question correctly? I mean, we're not talking about people who grow lettuce in soil, in a open soil, kind of like a greenhouse or otherwise, right? We're talking about when you talk equipment, you're talking about NFT systems, deep water culture.
That's my guess. The question didn't specify, but I would assume that because soil, obviously.
Yeah, you can do whatever. Yeah. Okay.
Yeah.
Well, that's a good question for maybe Sebastian or.
Yeah, Sebastian, do you want to go ahead or shall I go?
Both. It's a very wide question, I think, because of course it depends on what was the crop that you grew before, and also what kind of grow system you want to go afterwards. So of course, a lot of it can be reused, but it might not be the optimal choice. But if you already have the equipment and just want to get started, the plants will, you can probably make it work, and it will not be perfect, but it will be good. So you don't have to throw out everything on the first day, I would say. But of course, over time, it makes sense to maybe slowly replace it after also gathering some first experience on what you do and what works for you, to then start optimizing and getting the correct equipment.
Yeah, I think the aim you want to look for is a certain area where the plant can develop itself. So if I, for example, look for an ebb and flow system for, I don't know, microgreens, for example, there it will be very difficult for a strawberry to be developed due to the height. As microgreens will probably have an overhead of 15, 20, 25 centimeters. So for a strawberry, you need at least 10, 15 centimeters space between lights and canopy, and then the plant itself, I think the rough estimation should at least be 30 centimeters for the crop itself. And then, which is very important for the strawberry, you need to make sure that the trusses are supported, because the truss nicking leads to bad quality in strawberries itself. And another thing is that as you have a generative crop, you need to reach it certain times within its cycle. So if, for example, there are a very famous deep water culture for lettuce, in which you have like this kind of dry hydroponics, you can Google it. It's like a plate on water where you have your crops. And if you only plant them and then you chop them, so you have a basically handling twice at the beginning and at the end, it's all good. But if you have multiple handlings within the lifespan, you need to be able to reach, like the ergonomics is a very, very important topic here, because you don't want to go for strawberries and reach for 1-2 meters in the horizontal range. So get back to the actual growing system. I think if you want to grow soilless, our experience, the best way to do so is deep water culture, actually, because you don't have too much changing within the nutrient solution, as it buffers through the whole amount of water you have. So we've seen successful growing in deep water culture, but honestly, like the pathogens within this water is insane to handle. So if you don't get any pathogens, it's all good. But once you have them, there have been so many dramatic examples where the whole farm had to be erased, and even after refilling, it didn't solve the problem.
Interesting.
Can I just ask one more time, because it's somewhat new to me? So you were saying strawberries can be grown in deep water culture. Is that what you're saying?
I mean, as Sebastian said, they will grow in very different circumstances. But if it's perfect, or even good, or half good, or what's the next one? A quarter good, will be determined through the actual lifespan. So, of course, strawberry will grow even in an NFT system, or in whatever kind of combination you want to go for. I mean, we even tried aquaponics. And in all those specialties, they kind of work, and they kind of bring the system to work to this extent. And then you have your first flush, and this first flush should aim for 600-700 grams, depending on varieties. But if you want to go for commercial growing of everberry or juneberry, you should hit those targets in the first flush. And in an NFT, if the plant isn't developing as we are used to that, let's say like those 30 centimeters, but they rather stuck with those 15 centimeters, they obviously still produce, but then you have like in your first flush 50 to 100 gram, and then you should be asking yourself if that's successful.
But the deep water culture thing is interesting, because what you're saying is what they really dislike is fast changes in the, you said microbiome, but just in how they are living. And when you're in deep water culture, they're in a huge pool of water that mediates the whole thing. So it doesn't do the fast thing, right? So that's interesting.
But it also, yeah, as said, brings the risk with it that pathogens can explore the whole area very fast.
So maybe don't invest in a deep water culture,
Right.
but have one, you can experiment.
And what what I've seen on the, getting out of the root zone and now getting into the structure that the plants are living in, what I've seen that works is like the greenhouse structure, the greenhouse systems, for the most part, those can really stay quite similar to whatever you were doing. Obviously, light levels and whatever else have to be specific for the strawberries, maybe the appropriate amount of shade, whatever else. But if you pull out a grow system and just change the grow system, but keep the structure, that I've seen work fairly well. And even like what I would consider not so great greenhouses do a pretty good job, because strawberries are pretty happy when it's cool. I mean, happier. It's overheating that's really the biggest issue that we've seen.
And Josh, that's a good segue, because our next question is about supplemental lighting. So just moving to different systems now. People are very interested in the specifics of hours of lighting, spacing on the lighting, and how, the distance from the strawberries. So as much as we can just explore the topic of supplemental lighting in a greenhouse and a controlled environment, it would be quite different. I know
that's a Claas Sebastian thing. I mean, the way we do lighting is we don't do proximity to plant in a greenhouse. We look at an overall canopy footprint, and then we light map it. And so I actually don't even know what the PPFD requirements or DLI, which is lighting over the whole day requirement, is specifically for strawberry. It's not that high. But we would just appropriately lay it out. I think when you get to the indoors, when you're talking about proximity to plant, because you're trying to maximize the amount of rows of plants with light, and so you can't be 5 feet off the plant because you're wasting space. So you guys could speak to that. That's out of our room.
Yeah, so you're wasting space when you are far away, of course. So in a greenhouse, this doesn't really matter. When you want to do a multi-layer farm, it's very important. Also, a benefit is that you are a bit more efficient on the lighting when the distance is closer. But of course, especially when you have a big setup, it's much easier to have some bigger fixtures that cover an area instead of having a huge amount of smaller ones. And then, of course, on how much lighting is, you need to see what's available naturally, and then you can do the calculations on how much you need to supplement. And I think Claas can define it a bit better.
Yeah, but basically said it all right, and especially the terms of you try to be as far as possible away from the crop, so you can have one highly advanced light system which can cover a big area. But if you want to save space, you obviously need to get closer. Then you have way less wattages per light unit, and so on. And there is a certain sweet spot. If we look at the hybrid system, you of course need to do a simulation in terms of the past year's behavior on sunlight distribution, and especially the radiation spectra which is available. Because that also differs as well. Sunlight is not equal sunlight everywhere. So you need to do those measurements, especially on the sunrise and sunset. If we look at Germany, for example, the benchmark tells 1,400 hours of LED lighting per year, especially distributed throughout Q4 and Q1. And I assume that the further you go north from Germany onwards, this will increase up to 2,000, 2,500 hours per year in supplemental lights. But as said, in the end, which is most important, is that you have roughly 9 parameters for a strawberry to manage, and if a certain parameter moves out of that that particular range, you need to move all the other parameters in this same relation. And if you peak at certain points, you need to peak with other parameters as well. Otherwise, you're just wasting resources. And that's something where you try to be dynamic. So a dynamic light system in the end is obviously good, but it's also expensive. And so you always have to have a individual perspective on hardware decisions, which makes it so hard to have a hardware-based standard, even with complete enclosed environments.
So two things. The first I'm going to ask you, Claas, because you mentioned it last time we spoke, and just again, you're saying sunrise and sunset. And I'm curious if that's just a cool thing to say because it's fun to do with dimmable LED lighting, or is it really important for the plants?
To boost the sunset and the
I mean, I'm assuming you mean like you're dimming it up in the morning until it's daytime, and then
you mean in complete enclosed environment?
Yes.
Well,
or does it not matter? I mean, you just turn them on and turn them off.
As said again, in the end, I see rather close behavior from a strawberry towards a human than towards lettuce. So in the end, they basically behave almost the same. When you wake up in the morning with a flashlight in your face, you were like, "What?" And same thing with a strawberry. If you give them 300 ppfd in the morning, you'll be like, "What?" Okay. So you're inducing stress to the plant, basically. And whenever you induce stress, same thing with yourself. If you induce stress, you're using your managing capacity for relieving the stress, or you're stressed, and that leads to however we perform under stress. Anyway, what I'm trying to say is that the procedure is quite important to not change any parameters fast. And once again, kind of 9 parameters, do the sunset and sunrise in a certain appropriate timing, that the plant can actually get used to that sunrise or sunset, and we take roughly half an hour for each.
Okay. And I want to know, okay, test, what are the 9 parameters?
Oh, you got me there. No, so the main I would like to focus on, because they have the biggest impact, is temperature and light levels. So in the end, especially within a strawberry production, like actual strawberries, you count the growing degree hours. And then there's also other parameters such as humidity, such as CO2 availability, and then there is, of course, the root health index, and different parameters you try to describe the actual health standard of a plant. So if someone wants to know every parameter in detail, I can pass it over afterwards.
Okay, and then one more thing on lighting, because we haven't spoke about it. Strawberries are, I mean, this is my quick research. You guys tell me if this is right or wrong, but they're not a high light plant. I mean, we've dealt with high light plants that require a ton of light. Quick rundown: we have PPFD, which is instantaneous light, per second, and then we have DLI, which is the amount of light over a period of time to create a holistic light value for a day. Strawberries are like 300 to 350 ppfd, I think, and they're like 12 to 20 something DLI for a day. Do you have numbers that you work with, Claas?
Unfortunately, I have to say it depends, but the rough numbers are okay. We go in with 230 ppfd to 270 ppfd. That's our main course. Sometimes you go above, but that's mainly to just boost the plant. And then we come back to the crop strategy. The more you push the plant by increasing temperature and light levels, your plant material will wear out faster. Same thing with a car. If you're driving too fast all the time, it will wear down quite fast. Same thing with the strawberry plant. So I think it's a good picture to have in mind. And the DLI depends
how about
on
hours?
the daylight integral refers to the actual variety mainly. Let's take an everberry such as Favori. You go in with 15 hours constant light levels, and as said, half an hour sunrise, half an hour sunset. So in total, maximum of 16 hours, because the gene material is used to the actual day length we had for thousands of years or millions of years, and yeah, that's why the actual development of the gene material needs to be modified manually to discover a certain a gene to be able to produce, let's say, in 20 hours. If you want to go for yield, and if you want to go for energy saving, you try to obviously go for 10 hours-ish. So yeah, I'd say the range is roughly between 12 and 16 right now in the most used varieties.
Cool.
Okay, I think we have time for one more question. And it's to whoever wants it. What are the greatest difficulties when growing strawberries ecologically? And are there tips for making one's operation more ecological?
What do we mean by ecological?
Yeah, what's meant by ecological?
So, okay, but we can make it up. So like organic versus not. Like let's talk about organic
so.
for a second.
Yeah.
Like,
So one sec. So as we have a different understanding of organic in Europe, I would rather let's go for: are we using pesticides? Yes, no. Are we using LEDs? Yes, no. And
no, right. So you
chemical
can be
fertilizers.
Yeah, in the US, you can use LEDs. You can be indoor. That's fine. But let's talk about fertilizers, pesticides, herbicides as organic. So not chemical. There actually probably are some that are approved, but let's just talk about biologique, but just with what you're inputting the plants, not the light or anything like that.
Okay,
I'm also curious why lights are part of organic.
In Europe, is
classification.
sunlight part
No,
of it?
it's not ecological. Like
Oh,
you
okay, yeah,
try
bad
not
for the
to burn
environment.
coal
Okay.
to
Yeah,
boost an LED.
Yes, that makes more
It's,
sense. Thank you.
But how about organic inputs for pests and feeding? Do you do it organically? Do people do it organically?
Yeah, I mean, we have this protocol, especially when it comes to pesticides. We try not to use them. We try to use beneficials, but it's really tough to control only with that, because there are certain stages where you have pests inside your system, and you use your beneficials. It takes time to buffer, and if that buffer time is screwed up due to any reason, you need to use pesticides, otherwise you'll lose your whole system. And so to actually bring that question to an easy level, I would say to grow ecologically, you should do this in an individual manner. So meaning if the more industrialized you get, the more important is your production safety. And the less, the smaller your batches are, and you're not really into this whole economic game, then you can go for organic fertilizers, then you can use your beneficials and so on, because you be like, okay, whatever, if one crop fails, it doesn't matter. But if one crop fails an industrial system and it's spreading any kind of pest, that's not fun at all. So I think it's due to the actual risk mitigation through the actual amount to be grown, because there's so many different areas where it can become more ecological, yes, but then you sacrifice the production safety, and the production safety always relates to the size of the facility. So that would be my simple answer.
Mark, do you want to speak to, we use UV transmissive glazings, or we encourage people to? Do you want to speak to that at all in this regard?
Well, I mean, I think Claas mentioned it earlier for the bumblebees. They like the UV light. It will, so having a greenhouse, and you want to grow with the help of the sun, and you want to have a greenhouse, it makes all kind of sense to use glazing materials that will let UV light in, which most plastics don't. Being polycarbonate, what doesn't, polyfilm doesn't. Some specialty glasses can do that, and the ETFE does, which helps both on the taste side of the strawberry and the pest control, and certainly also the bumblebees. Apparently, I have heard that before, but it was good that Claas mentioned that before. So they orient themselves. They have sensors for UV, right, but not for the light spectrum that we see.
Yeah.
So that is an advantage of growing in a greenhouse in that sense, using a UV transmissible covering, and so that is certainly a helpful, one of the aspects to be helpful. And I did like what Claas said earlier, which was this issue of his 9 parameters that need to be changed. And I don't know that people really understand what that means. It just says, if one of the parameters, for example, light is very strong, and you're getting whatever 2000 ppfd because that's what the sun is giving you on a really sunny day, at least in many places in the US, at higher altitudes where we tend to be. But then how do you need to address, for example, the other parameters to optimize the growth of the plant in those conditions? Equally, when you are, and we have seen, you have, Josh, you have seen a bunch of greenhouses, and I have, and don't even need to talk about Claas and Sebastian. There's lots of greenhouses in Europe where they're growing in the middle of the winter without artificial lights, and it's cloudy days with ppfd levels of 150 maybe, right? And so you need to adjust all the other parameters to make optimal growth to have the plants be growing optimally in those conditions, right? They won't be growing quite the same as if they would have 500 ppfd or 1000, but they need to be, the conditions need to be right, otherwise the plants are going to be unhappy. And so that part leads to controlled environmental agriculture, and I'm talking particularly about controllers, right? So you need, just to grow that in a simple greenhouse is one thing. If you have a controlled environmental agriculture space that has controllers in it, that will actually make the adjustments of all the 9 parameters on one controller, which is part of what Claas is offering the input for. And our controller can do this. Sebastian has controls that will do that. And that's the whole part of creating a controlled environment to optimize the plant growth based on the conditions that you have. And I think that's a really important part that people underestimate.
Well, that's the input part, exactly. And only throughout the output part, we can obviously start labeling the actual leverage of those inputs. So this is where the benchmark is heading towards right now, to not only control the input parameters on certain set points, what we're used to automation, is to discover next to the actual yield, output parameters which influence this as well. So it's getting quite complex in the industry, and I can definitely encourage to dive deeper into that topic, because it's so mesmerizing to understand the actual behavior of a strawberry plant. Although it seems to be easy, but you can get so much out of that plant if you have a look, and transparency. And that's basically like the one way. If you go more ecologically, you implement so many more levels of uncertainty, and that it is very difficult to do this in like a big amounts and try to figure out the right ingredient. Rather get more transparency in the output and inputs, and then you can start managing, because if you can't measure, you can't manage. I learned someday. So yeah, but I think that's maybe the link to the ecological question, back to that route.
Great. Does anyone else have anything to add?
Yeah, maybe just a little bit concerning the if it's to be more ecological and stuff around. So generally reduce plastics that are just single use, especially in growing. There's a lot of use of things like that. Then of course also stick closer to the growing seasons that the plant is used to, because of course you can lower production footprints a lot if you don't need to heat your greenhouse. And then of course having a greenhouse that is optimized for the climate you are in, as well, because there's many different types of greenhouses, and yeah, you're the experts on that one, but and that can also be have a big impact on operations. So if you're in a colder climate, don't buy a greenhouse made for Italy. So that has a big impact as well. And yeah, I think that's also something that can be optimized quite strongly and without changing a lot.
Yeah, that's a really good point. And I think, it's like we think about organic and like what we're putting in our body, but the reality is that an appropriate designed facility for the climate is both a business case of how you're going to make money off selling your fruit, but there's also the ecological thought process to that, which is how can we reduce the inputs putting in as much as possible, which we do in the design of the structure, so that you don't need to burn the fuel or whatever it is to maintain the climate.
I did want to point out something that we talked about last time. We didn't really talk about this time, but we are in a time that labor to pick strawberries, to take care of the strawberries, is hard to find, is expensive, with labor rates going up. It's work that people don't necessarily want to do because it's really hard labor. And so to find the right amount of automation, not over automation. I'm not saying make all of it without people at all, because people have tried that and failed. The right sizing of the automation is a huge, important issue that in light of some failures of people who, again, tried not so long ago and put a lot of money into that, they went way ahead on the automation part. I think what we're trying to do is to find the right level of automation and the right in both the growing aspect as well as the picking aspect to make this at the end, for those of the listeners who want to listen and to create a business that is profitable or already run a business that is profitable, how to make that an even better business and ultimately also get better berries into all the consumers, including all of us, right? That's the idea. And so the solutions that we're looking for are individualized, so that I don't know that there is one thing that we can say this is the right thing for everywhere in the world. That's just not how this works. I think this is an individual solution based on your environment, about labor rates, about customer demands. That's a complex project, but we have a team together that, is trying to address that very issue to make it just the right thing for everybody. And that's that's what we're really proposing, I guess, most of what this seminar was about. Unless somebody has different opinions about where we're trying to go here.
Right. Haley, do you want to close this out?
Yeah, I think that's a good segue. Just to close us out and share contact information, not just for our team, but for Sebastian and Claas. We encourage people to reach out if they have specific questions about their project or are interested in getting into growing strawberries in the CEA environment. We not only do webinars with these two gentlemen, we also work closely with them. So we want to thank them so much for joining us again. I know that they are in different time zones, entirely different time zones, so appreciate your time in talking about strawberry cultivation. Yeah, so if you have any questions, please reach out to us or Sebastian and Claas. And yeah, thank you so much for joining us. And thank you to our panelists. And we will keep doing these sort of webinars, so stay tuned for the next topic.
Thank you.
Thanks, guys.
Thanks for having us.